So now I hope you're ready for a nice topic. It's called functions and graphs. I've called it this because it really ties a lot of the course together. The one thing about the new maths course that you're doing, the one that's been there since 2015, the new syllabus, is that there's no choice on the paper. You have to do all the questions. Before that, people had choices. They could leave bits out. You can't, because everything is integrated. All the bits are linked together. So I've chosen functions and graphs because it ties a lot of the course together, and you can also see it. So over the next hour, I hope to go through functions and graphs and show how algebra and graphs and calculus and intersections and all of these things come together in the one topic. And I'm going to start with a nice graph like this. Functions and graphs, it's in your notes there. Y is equal to x squared minus 2x minus 8. This is what they call a quadratic equation, in that it's got a square in it. So because it's a square, it's a sort of a shape like this. Now it could be a shape like that, but this one is a shape like this, like a bowl or a vase or something like that, or a rope sort of hanging, skipping rope or something like that. So that's what that is. It's a shape in that way. It's a squared shape. And if somebody says, what's interesting about it? Well, I suppose not a lot. It's just a graph, I suppose. But if you were pushed, you'd say, well, it's sort of interesting here and interesting here, because it crosses the x-axis here. So that's an important point, and so is that. It's almost like this is above ground and this is below ground, or this is outside the water and inside the water, or something like that. Or you could imagine a vase covered with this amount of water with flowers in it and the rest air or whatever. So that's what that shape is. So those 2 points are important. This point here is also important, this one here, because this one is sort of left and this is right, or west and east. So this one has always minus values on the x-axis, and this is plus values. So this is exactly below naught naught. And that's another interesting point. And this point here is even more interesting. This point here is the only point where the graph is horizontal. So if this was a vase and you had a marble here, it would roll all the way up and down and up and down and up and down, and it would eventually settle at the bottom. So that's what that would be. It's the only point where it's level at the bottom. We'll talk about that later. It's a magic point in calculus and all that stuff, and slopes and all that. But from a vase point of view, it's where the marble would stop. So there's 4 points of interest in this function. So if we were to look at them, we'd say there's the 2 points of interest first. These are points of intersection. Even though we don't sort of think about the x and the y as lines, we see them as axes, we just sort of draw them. They're sort of invisible to us. They're actually in their own right equations. So if we look at the actual graphs that we see sometimes, and we pull one up, we pull up a standard graph. Let's say something like this. This is the x-axis, and this is the y-axis. But if you look at it here, this is the point naught naught. And let's say that's 1 naught, and that's 2, 3 naught, 4 naught, 5 naught. Every value here really has sort of the sort of, it's naught 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 naught. So it's naught naught, 1 naught, 2 naught. So really that's the y equals naught line. Because all the xy's, we always have x, y as our coordinates. Always x first in the alphabet and then y. So we always go out and up, 3 out, 2 up. We always do it that way. So that's when we think about it. So 4 naught is 4 out and nothing up. So that's the point 4 naught. But every single second number here, naught naught, 1 naught, 2 naught, 3 naught, 4 naught, actually has a y value of 0. So the x-axis is really the y equals 0 line. And similarly, the y-axis here is actually x equals 0 line, because this is naught naught, naught 1, naught 2, naught 3, naught minus 1. the first number is always naught. So the x is always naught. So we've got two sort of strange things. We've got an x-axis where y is equal to 0, and we've got the y-axis known as x equal to 0. There are two lines. So back to this, what I'm really saying there is that these two magic points on the graph are where the vase or the function crosses this magic x-axis, or when the y value is 0, look at the y value there, 2 naught, minus 2 naught, and 4 naught. Here's another interesting part of the same graph. And on this occasion, we're talking about this point here. And this is the point where the vase intersects with the y-axis. So it's neither west or east, it's always the same. So what we see here is 0 minus 8, intersection with the y-axis, and the 0 is telling us that the x value is 0. So that's an interesting point. And the final interesting point is this one here, the minimum point on the graph, where it's horizontal. So there's the full summary. So if somebody asked you to say, describe this graph to me, well, you'd say it starts up high, it goes down, it turns and goes back up high again. At a certain point, it hits the level line, so it goes underwater here or underground. It comes back over ground here. So there's those 2 points. At a certain point, you're neither east nor west, you're bang in the middle. And at the very end, you're actually at the minimum point. So there are the 4 points about that graph. So really, a lot of the questions on your leaving certificate about functions and graphs are about things like this, and saying, with that graph, find out where it intersects the x-axis, find out where it intersects the y-axis, find out the minimum point, or sometimes just draw the graph. Sometimes they ask you to do this by eye, by just looking at the graph and saying, oh, I think it crosses at about 4 naught. Sometimes they ask you to calculate it exactly through algebra. And sometimes they ask you to calculate it exactly using calculus. So they're the sort of things that we'll join together. So if you were looking at the maths.griffith.ie site, you'll see that I've come to the next slide called Functions and Graphs Plotting Points. So again, I have this rectangle here, which says this is a new area. So if you want to just click on the video for this little part, then that's fine. If this is the bit, I know all that stuff, but I don't know how to plot graphs. So I'm going to look at those plotting points. Then you can skip all the other ones because you know all the other ones. So you just fill in the particular stone you need to print in your own right. So what I'm going to do now is I'm going to, given the same graph, here's a question. fx is equal to x squared minus 2x minus 8. And I'm saying, let us now draw that graph. Now, this is strange. We're now seeing something like fx is equal to x squared minus 2x minus 8. This is different. We're used to y is equal to x squared minus 2x minus 8. It's actually the same thing. We're always going to have something on the left and something on the right. Sometimes we call it y as the actual y-axis or the y value, and sometimes we call it the function of x, but really we mean y equals. Because whatever number we get here, let's say x is 0. 0 squared minus 2 times 0 minus 8 would give us minus 8. Then we would say when x is 0, f of x is minus 8. Or when x is 0, f of x is minus 8, or y is minus 8. Or in other words, xy, the point, is 0 minus 8. And I think we saw that before. We saw that 0 minus 8 was actually the value of the y when x was 0. X is 0, y is minus 8. So that's our value. So don't be put off with this fx thing. It's just really another word for y. So they're saying plot the function. So one of the things you have to be able to do in the Leaving Cert, it's on the Leaving Certificate syllabus, and that's why there's a topic on it. It says, can you plot graphs? So for f of x equals x squared minus 2x minus 8, can you plot those values? So you say, what happens when x is 0, when x is 1, when x is 2, etc. So what you do now is everywhere you see x, you put in a 0. So in this case, you'd say 0 squared minus 2 times 0 minus 8. 0 minus 2 times 0 minus 8 is minus 8. F of 1, we'd say 1 squared minus 2 times 1 minus 8. So that's 1 minus 2 times, that's 1 minus 2 minus 8, that's minus 9. F of 2 is 2 squared minus 2 times 2 minus 8. 2 by 2 is 4. 2 by 2 is 4. 4 minus 4 is 0, minus 8. So the points I get will be 0 minus 8, 1 minus 9, 2 minus 8. And let's see, are they roughly what I'm getting on the graph? 0 minus 8, 1 minus 9, 2 minus 8. So it looks like those graphs are right. And you could do the rest for all of them. Usually it'll tell you, do it for all the values from minus 2 to minus 1. So start at minus 2, minus 1, all the way up between minus 2 and 4. So they wanted you to start when f was minus 2, all the way to 4. So taking f of minus 2, we say minus 2 squared. Anywhere where there's an x, we put in minus 2. Minus 2 times minus 2, minus 8. So that's 4. Plus 4 minus 8 is 0. So you have all of those. And again, we're seeing when x is minus 2, the graph is at 0. So that's how that works, and we plug in the numbers. It's a minus 5 there. Minus 5 is in your notes, and it's minus 1. When it's minus 1, it's minus 5. Okay? So we plot those values. When we do that, we can then put them on our graph. So the answers we got of minus 2, 0, minus 1, minus 5, we can draw them on our graph paper. Just as we did there, we can get our graph paper and draw them. And then you can buy one of these things for a few euro in Tesco if you can get to them. They'll certainly be open long before your exams again. And it's just a handy way of just getting a stretch drawing or something like that, where you can draw a line like that. Buy them for maybe 3 or 4 euro if you want, or whatever. You'll find them. And it just allows you to join up the points so you get a nice graph if you can. And then we just do a nice one in the bottom there if we can, as best we can. So it looks smooth enough. Now you can do it by eye. You won't lose marks for not doing it as with the device like that. But you get an idea of that's the graph. So that's one of the things you have to be able to do. It's called curve fitting. And you say, can I, with the graph, plot it? So your task in this particular section is fairly straightforward. It's can I, with the function, plug in values and be able to draw it. And that's the end of that topic, completely. We'll now move to another topic. Here's another topic that's required of you on the Leaving Certificate. It's one of the Department of Education's requirements. It's called intersecting axes. Can you figure out, when you get a graph, where does it actually intersect with the x-axis? What are these values? Let's say they weren't given to you. How would you find out where that function, x squared minus 2x minus 8, the blue function, how would you find out where it crossed the x-axis? How do you do that? Well, what do we know about these two magic points? Well, not only are they on the vase, or the vase, or whatever you call it, but they're also on this line here. This is a line. It's not just something that's invisible. It's the x-axis. And the x-axis was another word for y equals 0. So really what we have now is we've got a y equals 0 line intersecting with another function. In other words, at these 2 points here, let's call them A and B, not only are they on the curve, but they're also on the actual line itself. So in one way, they're on the curve. Y is equal to, let's write it down, they're on the curve. So even though they're on the curve, we know that y is equal to x squared minus 2x minus 8. But they're also on the x-axis. So they're also equal to y is 0. So if these two things are true, if the y value is not only this one, that, but also y equals 0, and y must equal y, x squared minus 2x minus 8 must equal 0. So now we've got an equation, and you've seen lots of these, not in functions and graphs, but generally in algebra or something like that, or quadratic equations, nothing to do with graphs, but that's where you'd see it. And the question is, can you solve that now as a maths problem from another part of your course? And there's a few ways of doing that because you do know how to do that. So let's see, how would we solve that? How would we solve the equation y, or fx, equals x squared minus 2x minus 8? In other words, equals 0. So x squared minus 2x minus 8 is 0. Just this bit here. Well, there's two ways of doing it. You can use a thing called factors, and some people will remember those. And they'll say, to get x squared, we use x and x. To get 8, we could use 8 and 1. I don't think that'll work. 4 and 2 might, so try 4 and 2. We want the 8 to be minus, so one of those has to be minus. Overall, we wanted minus. So we could get x plus 2 by x minus 4. And we could say that's equal to 0. And we could say they're the factors. So x plus 2 times x minus 4 is 0. Well, if that's true, then either x plus 2 is 0 or x minus 4 is 0. And if x plus 2 is 0, how do we solve that? If x plus 2 is 0, we don't like 2 on this side, we take it to the other side, or we put in a minus 2, whatever way we want to do it, x is minus 2. And similarly, if x plus 4 is, sorry, not x plus 4, if x minus 4 is 0, we don't like minus. If we were to add a plus here on both sides, we'd get x equals 4. So it looks like when x is 4 or when x is minus 2, it intersects the x-axis at 4 or at minus 2. So that's great. That looks like we're right on that. So for people who remember those, that's fine. You've got the answer. You did it nicely. But not everybody will remember that. Not everybody will be able to do it like that. So let's see how else we can solve this question. So you're now faced with solving x squared minus 2x minus 8 is 0. Now, luckily, in the junior certificate, you had this great technique called the x equals minus b thing that unlocked these quadratic equations. So basically, it was the minus b plus or minus equation. So let's see if we can do this. It was the x equals minus b plus or minus b squared minus 4ac over 2a. And this was in the log tables. You didn't have to remember it in any way. So, and that works for every single quadratic equation. Ax squared plus bx plus c. So what I do now is I go into lockdown mode. Well, bad term, I suppose now, but I go into sort of concentrate mode. And I say, what's the first coefficient? Well, the a is ax squared is x squared. A must be 1. B is minus 2, so the minus is important. And c, the constant coefficient, is minus 8. So I said, okay, in this equation, a is 1, b is minus 2, c is minus 8. How do I solve it? Okay, a is 1, b is minus 2, c is minus 8. This is the formula from the maths tables, minus b plus or minus. I'm just copying that in. And I'm now going to transfer it carefully, step by step. So minus b is minus 2, minus by minus is plus. Plus or minus the square root of b squared. B squared is minus 2 squared. Minus 4 times a. A is 1, c is minus 8. Over 2a, 2 times 1. And I sort of come up for air then. I've written it down and I say, right, I now just have to step by step go through it. Plus 2 is plus 2. Minus 2 squared is 4. 4 by 1 is 4, by 8 is 32, minus by minus is plus. So that's 32. 4 plus 32 is 36, all over 2. So I've plus 2 plus or minus the square root of 36 over 2. The square root of 36 is plus or minus 6. So now I've got 2 plus 6 is 8 over 2. 2 minus 6 is minus 4 over 2. 8 over 2 is 4. Minus 4 over 2 is minus 2. Note I'm getting 4 and minus 2 again. 4 minus 2 are the roots, not the factors, the roots. The roots that say x is 4 means that when x is 4, we're neither above ground or below ground. When x is minus 2, we're just on the level there as well. And therefore, when x is 4, x minus 4 is not, x minus 4 would be a factor. And that's how that's done. So we have now got the intersection of points with the x-axis. Another part they require on the leaving cert is to get the intersection with the y-axis. How do you do that? Well, we look down for the intersection of the y-axis and say, well, it looks like it's cutting here at 0, minus 8. But how would we do that? Well, remember that the equation is x squared minus 2x minus 8, or y equals x squared minus 2x minus 8. But also, what's special about the y-axis? Well, the y-axis is another word for x equals 0. So if x is 0, we just plug in 0 everywhere there's an x. 0 squared minus 2 times 0 minus 8 is minus 8. So the y value is minus 8. The x value is 0. xy is 0 minus 8. And that is the point of intersection. So that's it. And that's the intersection of lines. So you can look back on that section and then say, right, if I'm given a graph, can I figure out where it intersects the x, where it intersects the y? And that section again, this whole section of functions and graphs, you can then say, don't need to see that again. Okay? So we take a breather for a minute and we just look at checking graph values. This is a reasonably straightforward section, and it says, is the point 0.3 up here on the graph? How do you know that it is or it isn't? Is 0.3 on the graph, on this graph here? So the graph was y equals x squared minus 2x minus 8, and is the point 0.3 on it or not? So what you do is you put in the x of 0 and see if y comes out to be 3. So we're checking. So we're going to put in the x value of 0. Everywhere there's an x, we're going to put in 0. So 0 squared minus 2 times 0 minus 8 is minus 8. So this says when the graph is at, when x is 0, coming along here to 0, Actually, the y value is -8, not 3. So I'm getting -8. That's not 3. Not 3 does not satisfy the function because -8 is not equal to 3. So it's not on the graph. Sometimes they ask you to do some nice work with graphs then, and they show you the graph, and they say, describe on the graph where f of x is greater than 0. Now remember, this f of x thing, it's just there to, I'm not saying it's there to annoy you, it is the function x, but really if it's not x, it must be y. So f of x is really y. That's all they're saying. So when is the y value greater than 0? So when in all this space is the y value, where are we above ground? And it's clear we're above ground here. We're certainly above ground here, and this is the bit underwater or whatever this is. Okay, so this is above ground. So when f of x, where f of x is greater, or y is greater than 0 here, where we're below -2, and we're above 4, we're also above ground. So they're the two of those. So really what we're saying is that when x is less than -2, and when x is greater than 4, we're above ground. Now, when we're equal to 4, we're on the ground. And we're below 4 here, we're underground. But we're above 4, we're above ground. So we can do that this way and say, anytime when x is greater than 4 or x is less than -2. So when x is less than -2 and when x is 4. Now, sometimes it's nice to write these out in a slightly neater way. And we say something like x is less than -2 and x is greater than 4. Sometimes it's nicer to sort of do those in order. So I'm going to turn this around. So x is less than -2. If I go from x to -2 on a journey through this page here, I hit the pointy bit first, and then it opens out. If I go from -2 to x, I hit the open bit first. So I'm going to write -2 here, and I'm going to go to x here. But from -2 to x, if I travel, it goes like that. So I've turned that around. So -2 is greater than x. And x is also greater than 4. But x is x. So -2 is greater than x is greater than 4. It's just a way of writing it as a single line if you want. And sometimes they write it like that in the exams, and they're really saying this applies and this applies. They're hiding two equations in one. So all I did there was I did the same, and I got -2 is greater than x greater than 4. And that's how we would say when the graph is above ground. And that's the end of that section. That topic is done, and we now look at the next topic. And we then start saying, okay, how do we look at functions and graphs now when we're intersecting with lines? So for what values of k does the function y equals k intersect the function twice? Now, this is a bit trickier. So what we're saying here is that imagine you've got a straight line or a straight edge or something like that. I'll just get a ruler or something like that, or maybe just do it with white paper. If I've got a straight line, and here's my line across here, and I start cutting through, you can see here that this would cut the vase twice, just about maybe twice. But if I go further down here, I'm not cutting it at all. So down here, I'm missing it completely. So what line actually stops cutting the graph? Is there a line here that stops cutting the graph at all? And what is that line? It looks like it's around -9, but we'll just look at that and see. So the exam question was, what values of k does it intersect twice? So we start looking at the graph here, and we're saying clearly this line, y equals 4, intersects it twice. So does this, so does the x-axis all the way down. But this one here only intersects it once. And how would you find it? Well, they wanted you to do it by eye. So by eye, you'd say, I think it's around -9. So y equals -9. So any line above -9 will intersect it twice. And that's if you were asked to do it by eye. But you might also be asked to find it exactly through calculus. And that's where this gets interesting. So we're on a topic called functions and graphs, another box, another rectangle, maxima and minima. You know, uas luach agus ias luach, though I should have thought you'd have course as Gaeilge. So what we're looking at here is we're looking at turning points, and we're looking here is when the slope is horizontal. So the curve changes or turns. The slope, you know, or the fauna is 0. So here we've got f dash x and dy dx is 0. Now, when mathematics started, lots of people were working on it all through the Middle Ages, and there were people who liked the term dy dx and people who liked the term f dash x. Two different schools of calculus thought they're both the same. They're not different. It's the same thing. So if they're looking for a slope, they mean f dash x or dy dx, or actually m from the linea or the line. It's the same thing. A slope is a change in one thing from another. So if you happen to be going up the stairs and there's a particular slope of that stairs, or maybe a moving escalator, or maybe if a moving escalator in a supermarket would be at a slightly lower angle, you might fall off and kill yourself on that one. But this might be lower with the trolley. Basically what they're saying is that as you go out a certain amount of step x, you go up a certain amount in y. So maybe for every 5 meters in x, you might go up 2 in y. So that's your delta y, your change in y, and that's your delta x. dy over dx is your slope. It's this over this. It's that over that. dy over dx. It's the vertical over the horizontal. If this was an angle, it would be the tan of the theta. If it was a line, it would be the slope m. So m is tan theta, is dy dx, is f dash x. Don't worry about those. We'll do those later. But I'm just saying that actually the chapter on the line and the chapter on trigonometry are all the same as the chapter on calculus. And the chapter on calculus has 2 ways of saying the same thing, dy dx and f dash x. So they're saying, when is the slope 0? So if we imagine the vase, when is the slope 0? When would the marble stop rolling? That's what we want to find out. So we look at the turning points and we say, calculate the derivative of the function, right? Dir hiok, or, you know, dy dx, right? Calculate from dir hiok of the original function. So if y is equal to x squared minus 2x minus 8, what is dy dx? And what we're looking for here is we're saying, well, how do we do this? Well, for the moment, let's say we know the rule. You have a number here, 2, you take it down. If the number was 2, you reduce it by 1. So it's not 2x to the 1 or 2x. If the number was just x, if it's just x on its own, you can get rid of it, but leave the coefficient. So it's 2x minus 2. If the number was a constant already, it's not changing. So there's no dy dx anyway. So if you imagine a line here, and the line, that's 0, 0, and this is the line minus 8, k equals minus 8, there's no slope on that. It's very, I'll do it. There's no angle on that. So it's still no, so there'll be no dy dx. So dy dx of minus 8 goes, that goes minus 2. So that's dy dx. So dy dx is 2x minus 2. So what does 2x minus 2 mean? Well, 2x minus 2 is dy dx. 2x minus 2, dy f dash x is dy dx is 2x minus 2. Always, always, every single time the curve has a slope. It has a slope here, it's going down. A slope here, it's level. A slope here, it's going up. So the marble will fall back here, fall forward here, and stay here. So it always has a slope. this. But we're not interested in it always. We're interested in when is that slope equal to 0? When is the slope horizontal? When would the marble stop? So when is 2x minus 2 equal to 0? That's an equation. We don't like anything on the left-hand side except x. So I don't like the minus 2. 2x minus 2 equals 0. How do I get rid of the minus 2? I say plus 2. So 2x is 2. I don't like the 2x. That's a multiplier. I'm going to divide. X equals 1. So what I find is that the derivative, d here, dy dx, f dash x is 0 when 2x minus 2 is 0, when 2x is 2, when x is 1. So when x is 1, x is 1 here, I go down, I can find that the slope of the graph is 0. Not the graph. The graph itself is minus 9. Because it's minus 9, it's 9 inches or meters underwater or whatever that would be. But the slope is 0. So dy dx is 0. The function is still minus 9. So f of x is minus 9, but f dash x is 0. dy dx is 0, y is minus 9. Okay? So find the value of the original function at the point. So what I want to do now is I want to find out not only, I don't just want to find out the slope, I want to find the value. So to find the value, I say, well, f of x was always x squared minus 2x minus 8. So f of 1 is 1 squared minus 2 times 1 minus 8, and then is minus 9. So the local minimum point is 1 minus 9. And now we look at that. There's the minimum point. There we go, f dash x is 0. We can see it's horizontal and all of that, and we're sorted. So that's it. That's how we do that particular question. So we now have dy dx, calculus linked to our graphs, linked to equations and roots and all of that. Now, and we'll move to the next topic. The next topic, if you were to look at the maths.griffith.ie site, there'd be a small video on slope values. How do you find out the value of a slope? Well, we know when the value of the slope is 0, that it's a minimum or a max. But we're now going to do it for slope values in general. So here's a value, here's the function of the graph, here's the whole thing. And what we're doing then is we're saying, okay, here's our graph. When is the slope greater than 0? Greater than or less than 0? When do I start going up the hill? Well, it's clear here that I'm going down, 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 the ball would fall all the time. But once I get to the bottom, it will start moving up the hill again. So I think that the screen is just taking a little while to focus on this particular slide, and hopefully it'll get there. So basically we're trying to move up the slide on this particular screen. Okay, so we want to find out when is the slope greater than 0. And the slope is greater than 0 when it gets to 1 minus 9. Now the camera has settled down. It didn't like those hashed lines, so apologies for that. So find the general expression of the slope, or derivative of fx is equal to this, or y is equal to x squared minus 2x minus 8. What's dy dx? For x squared we get 2x, and for the 2 minus 2x we get minus 2. Find when the derivative is equal to 4. Find when the slope is equal to 4. When in this graph, and again, forgive the jumping of it, when is the graph moving at a slope of 4? When is it moving up in this particular direction here? When are we moving for every step out? Are we going 4 steps up? Well, what we do there is we say, when is dy dx equal to 4? So when is 2x minus 2 equals 4? Well, 2x minus 2 is 4. Don't like minus, I put it on the other side. When 2x is 6, don't like 2x, want to get rid of it, x is equal to 3. So when x is equal to 3, out here, at this point here, and I go down here, the slope is equal to 4. Okay, for every step out, I'm going 4 up. Find the value of the function at that point. So when x is 3, what's the value of the function? Again, we've got f of x is equal to x squared minus 2x minus 8. So we put in f of 3 into that, and we find at 3 minus 5. So if I go back to the original graph, at 3 minus 5, at 3 minus 5, there's the function, there's the point 3. At this particular point only is the slope equal to 4. For every 1 step out, I'm going 4 steps up. So for every 1 step, I'm going 4 up. 4 over 1 is the dy dx. 4 over 1 would be the tan of this angle. 4 over 1 would be the slope of that line. So that's how we do it. That's how we do that graph. So joining the thing together, we'd have the point 3 minus 5. How do we do it? Well, that was the original function. That was our y. dy dx was the slope, which was 2x minus 2. We wanted the slope to be 4, so we said make it equal to 4. The only place it was 4 was here. We then said if x is 3, then y must be minus 5 from this equation. So at 3 minus 5, the slope was 4. The slope was 4 is for every step out, we go 4 up. Slope is dy dx, or m, if you were doing the Lena, Fon and Lena, the slope of the line, or dy dx. Or 4 over 1, because this is 90 degrees, is actually tan of theta. So tan of theta and m and dy dx, or f dash x, whatever way you call it, they're all equal to 4. And that's the end of that. So we've joined up a fair bit there. We've joined up, hopefully, the line, a bit of the line, the slope, the dy dx, the tan, and the trigonometry, and all of those are coming in together. So just wait for this to come in and say hello to us. Now, so the camera is doing serious work trying to adjust to all the hash lines and all that. So hopefully you're receiving all this okay. And we just take another breather or two. We're close to the end of this session. Remember what we're doing. We're trying to say that every single possible topic that the Leaving Certificate examiners can ask are covered in each of these sections. You know most of them already. You've seen them all before, but some you didn't catch at the time, or you may have to look at again just to fill in the gaps. So that's what we're doing. So if you have a gap in a certain thing, go back and look at this particular spot and say, yeah, I'll have another look at that. That was a bit that's tricky. But every single one of the exam questions, every single one, are taken from absolutely these identical questions here. All the skills you've got to do. So to plot a graph, to actually find its intersection, to find the dy dx, to find when the slope is positive or negative. And some of those times you're doing it by eye. You're just saying, I can see the graph is good there or not. And sometimes you're doing calculations. So the next one now, we're sort of moving a little bit from functions and graphs into the area of lines, but just to show you where it connects. Find the tangent to the function f of x equals this at the point 3 minus 5. So if we go back to that particular graph we had, we're then saying, okay, we have the graph, but how do we find the function, or how do we find the line and the tangent at that particular point? So how do we actually get that? Just bear with me a minute and I'll pull up that slide if I can. Now, so what I'm saying here is that how do we find, given that we found the point, and we know the slope, how do we find the equation, or cortamoid on líne sin, cortamoid on tailí, the actual equation for the tangent line itself? How do we find that? So what is that? Y is equal to what? What is that line? We don't know. So we're going to do that now. So find the tangent of the function. So x squared, so y is equal to x squared minus 2x minus 8. Well, we've done all this. We found the slope, and we found that the slope was equal to 4. That was our step. So we found that the slope, dy dx, was 4. That's also equal to m. So given that m is 4, and the point x1, y1, 3 minus 5 is on the line, if you have a point and a slope, and you want to draw a line, it's in the log tables. You can look it up. So the equation is in the tables, and it says y minus y1 is equal to m into x minus x1. This is exactly from your Leaving Cert tables. But the x1, y1 is 3 minus 5, and the m is 4. So we go into this concentration zone, and we just copy the numbers in. So y minus y1 is minus 5, minus by minus is plus, so y plus 5, m is 4, copy that in, x minus 1, x1 is 3, so minus 3. So we now have this line here, y plus 5 is 4 times x minus 3. And that's just an equation, so we're going to tidy it up. Now, sometimes we just like one thing on the left-hand side, and sometimes we like two things or whatever. So let's assume we just want y on the left-hand side. How do we do it? Well, let's go through it. Y plus 5, I'm going to multiply in. 4 times 4x is 4x. 4 by 3 is 12. 4 by minus 3 is minus 12. So it's a bit better. Still have too much on the left-hand side. I'm going to turn the thing around. 4x minus 12 is y plus 5, because that's the same as y plus 5. Don't know why I did that. I just tidied it around if I wanted to. 4x is equal to, I'm going to take the 12 over. I don't like that minus. I'm going to put plus 12 there and plus 12 there. So they're going to cancel. So 4x is equal to y plus 5 plus 12. 5 plus 12 is 17. So 4x is y plus 17. 4x minus y is 17. Sometimes we see lines written like that in simultaneous equations. Or sometimes we see it as if 4x, let's finish now. If 4x minus y is 17, and I just want y on one side, I can say, okay, I'm going to put the y on the other side. So 4x minus y plus y is equal to 17 plus y. Then I get 4x is 17 plus y. I don't like the 17, so I'm going to make it a minus 17. So I'm going to get y is equal to 4x minus 17, or really y is equal to 4x minus 17, the right way around. So that's another way of getting the answer. So I now have just one thing on the left-hand side, my y, and the other is my 4x minus 17. So that's it. So there's my equation, y is equal to 4x minus 17, and that's my tangent. And think of it. If y is equal to 4x minus 17, what's dy dx? dy dx of 4x is 4. dy dx of 17, 0. So dy dx is 4. dy dx is m, as before. So dy dx, slope, 4, tangent, line, all tied together. And that was when we called it y. If we had called it f of x, it would have been exactly the same question, and instead of dy dx, you might have called it f dash x. So it doesn't matter how they give it to you in the exam question, whether they call it f dash x or dy dx or m or anything else, you can do it. It's the same techniques you were using. So we now move on to another topic. We're getting close towards the end, and we'll go with intersecting functions. Intersecting functions now is where it gets a little bit interesting. And they say, find where the function, the same one we've always had, intersects the function gx is minus x minus 2. There's nothing different between f of x and g of x. It's just another thing. So find out when they're equal. So if you can draw this one, you can draw this one. What did we do before? We just plugged in numbers here for this. Anytime x was 0, we plugged in 0. When x was 1, we plugged in 1, etc. So we're going to do the same here, but the equation is a bit simpler. So when x is 0, we just plug in zeros, and when y is 0, we put, or when x is 1, etc. So when we did it for f of x, we can do that. Now, it says, when are these two the same? When are f of x equal to g of x? Well, really what they're saying is, when is x squared minus 2x minus 8 equal to minus x minus 2? This is just an equation. So what we do is we can take the x over to the other side. If we take that x over to the other side, it becomes a plus. So the x squared stays. X on this side becomes plus, so that'll be just minus x. And the 2 coming over would be a plus 2. That would be minus 6 is 0. So this equation here is the same type as this. It's a different exact equation, but it's the same idea. It's got a square and an x and a number there, and we can just find the roots of that. If we wanted to find the roots of that, we can do it through factors. We can say x and x. 6 would probably be 3 and 2. Minus and a plus would sort it for us, and we get the factors. So the roots would be when x is 3 or when x is minus 2. If we didn't spot that, we could use exactly the same technique as before, put in the ax squared bit, use the coefficients. A is 1, B is minus 1, C is minus 6. Plug in all the answers as before, just as we did a minute ago, and we find that the roots are at 3 or at minus 2, exactly as before. So they're the points when the two graphs are the same. So calculate the points when they are the same. So, draw the graph of gx now. Well, you've done this before. This was just plotting graphs. So when g is 3 minus 2 is minus 5. When g is 2, minus 2 minus minus 2 minus 2 is 0. So there's 2 points of intersection when gx and f of x are the same. I'm going to check that these values 3 and minus 5 and minus 2 and 0 are also on the f one, because I know they're on the g and I'm saying they're on the intersection, but just to check, when f of 3, I get minus 5, so that's 3 minus 5. 3 minus 5. And when f of minus 2, I get 0, the same again. So they're exactly for both. Now, they might have asked you to do that in algebra, but if they were lucky and gave you a bit of time, you might have been able to see the whole graph. So here's the graph then of f of x, the blue one, the vase that we always had. Here's the g of x, a red line coming through it. And what we see here is that they intersect in 2 places, when x is minus 2 and when x is 3. So minus 2 0 and 3 minus 5. And that's it. So we look now and we say, from observation, when is f of x, when is the blue line or the blue curve bigger than the red one? Well, I think it's bigger here from this point on, and it's bigger from that point back. But in the middle bit here, from -2 to 3, the red line is higher. It doesn't go as deep as the blue line. So when is f of x greater than g of x by I? You just look at it and you say when x is greater than 3 or when x is less than 2. So greater than 3, the blue line wins, or the blue curve. Below here, the blue one wins, but here, the red one wins. And you say between -2 and 3. And there's a picture of it then, and I know the camera won't like this too much, but there's the actual shading of it. That's not too bad. And we can see that above that, f of x is bigger, and f of x is bigger again there. And that's it. Now, we have a few more minutes to go, and we'll just finish the topics, I think. Now, inverse functions. There's nothing different about these, only they look prettier. That's all. So here you're asked to plot the function f of x is 1 over x plus 2. In other words, plot y is equal to 1 over x plus 2. There's nothing fancy about it, really. It's just different numbers for x. So if it says between the values of x equals -6 and +2, you say what happens when f of -6, f of -5, f of -4, etc., where f of x is 1 over x plus 2. So 1 over x plus 2, we 1 over -6 plus 2, 1 over -5 plus 2, and you put in all the answers like you would for anything else. You go from -6 to 2, and I've done them here from -6 to 2. I've done them all the way up to 2. And around the number 2, I just said, don't do it at -2. So just for fun, I did it at -2.5 and -1.5. And the values I get are pretty. I get this graph here. It's just nice. It's just a nice, pretty graph. That's all that's on in that. It's just pretty. That's called an asymptote. It just never actually hits that line of the x equals -2, you know, but it nearly does. But it's just a pretty graph. And now the very, very, very final section. And it just takes a minute, and then we should be finished. It's other types of graphs completely. Nothing to do with what we've done so far. They're not nice and curved. They're a bit strange like this sort of graph here. Now, you've seen graphs like this sometimes on television. If you've ever watched a sort of a documentary in medicine, an ER or a Holby City or something like that, you'll see graphs like this where somebody is not well and you have to get worried about them. And you're really hoping that it gets very, very tense, and you're hoping they're going to get better, and then suddenly they're back and everyone's happy again, or they're not, and it's a sad ending or whatever. But basically, what happens there is there's a pattern, and we can see the same pattern repeating all the time as we go back, and we can count that pattern. So here's a picture of a graph. It's called f:(x) arrow fx, another fancy way of lettering, but it's really y equals. And it says, in this graph here, identify the period and the range. So how often does it repeat, and what are its lowest and its highest values? That's all you have to do. So what I do here is I take a high point and a high point, and I say, how far apart are they? And this is the value 6, this is 16, that's a gap of 10. You could have picked the lowest points there and there, and they'd have been 10 apart as well. So it repeats every 10 units. What's its highest and lowest value? -1 and +3. You just look at the y values. So you read it from the graph. So the question here is, find f of 4 from the graph. Find the value of y when x is 4. So you go out to 4, x is 4, you go up and have a look, and you say it's the point 4, 2, y is 2. That's all you have to do. And the last one, it says, what is the value of 84? So this graph goes to 10, 20, but 84 is way out there, far, far, far to the right. So how do I get the value of f of 84? Well, the good news is that 6 is the same as 16. 2 is the same as 12. It looks like every time you can take 10 away and the pattern's going to repeat. So we can take the f of 84, take away 10 and get f of 74, and it'll be the same. 74 is still not on the graph. Just keep on taking 10s away. 64, 54. Just why not f of 4? And f of 4 will be 2. So what we do, if we're asked to get 84, is count away, take away as many 10s as we want. I think we can take away 8 10s. That gives us f of 84 is really f of 4, and that's 2. So reading from the graph, you can see the picture there. It's 4, 2, 14, 2, and likely to be 24, 2 all the way along. And that is finally the end of that session. I'm going to start by saying thank you to all the people who've asked questions, and I'd like to go through those questions with you now. Just waiting for the camera to focus here for a moment. Okay? And it will come, I'm sure. Now, okay, so the first question is, I've got a drawing and I've got my graphs here and I've got a curve, and somebody says, how do we know that that's a max point? Or how do we know that f dash of x at that point is 0? So what happens here is, if I move across at any point here, you can see that at this particular stage of my journey, as I'm going east, I'm also going north. I'm going up all the time. So as I walk along here, I'm going up the gradient as well. So at here, obviously, for every change in x, there's a change in y. So the delta y and the delta x, that's quite steep. I'm going up quite a steep mountain, whereas here I'm going down a steep mountain. But at this particular point here, that small bit of x, I'm not going up or down any amount of y. So the change in y and over the change of x has gone. Here I'm going down, here I'm going up. So there must be a magic point where I'm not going up or down. And that's where dy dx is 0. And dy dx is just another term for f dash x. So when it's 0, it means that I'm on the horizontal. I'm either no longer going down the valley, no longer going up the mountain. I'm just across the top. Now, somebody else asked, how do you know if it's a max or a min without drawing the graph? And you don't, unfortunately, because if you draw the graph, you can do it. Now, if you didn't want to draw the graph and you said, I don't know whether this point A here, let's call that 1, 2, 3, 4, 5, 6, 7. Let's say that's the point 7.5. And you don't know whether that's a max or a min. You know it's got dy dx is 0. You could take the value at 6 here and the value at, say, 9 here. And if it's gone from sort of higher than that to lower than that, then you'd know that it's a max. Whereas here, if you had taken this value and this value, you could see that the values were going lower in that range. So you don't have to draw the whole lot. Just take a point before it and afterwards and find out if it's a max or a min. So they were the questions on that. You don't have to prove that generally it'll say find the max and you can find it with dy dx or prove that, but that's one way of doing it. Okay. Now, there was a question I asked about a nice graph in the first section. And it was a graph where I had it something like this. I had the graph going, I think it was like this. And it was this inverse graph like that. And I call this line here an asymptote. It's not necessary that that will come up. It's just that any equation you get at all that you're asked to draw can look like any graph. You're just plugging in numbers. If you plug in numbers where it's y equal to 1 over x plus 2, you'll get a nice pretty graph like that. That's all. You won't be asked about the asymptote, certainly not in the functions and graph questions like that. You just plot the graph and the numbers will look after themselves. So when you're drawing the graph and you're plugging it in for the exam, you'll just have got your points and you'll have done something like this. You'll have a point here, point here, a point here, a point here, a point here, and then you'll have other points here. And you'll be trying to make sense of it. And when you get your nice curve shape into it, you'll find that it's like that. And the graph will draw itself. So that's all that happened on that. So that's the end of that question.